Hello, everyone, and welcome to our introduction to Kaggle workshop brought to you by Ed Intelligence. Special thanks to Naman Makkar and Mohara for the slides. And thank you very much, Linda Mazanova and Prakash Nair for helping with the organization of the event. So about this event, the purpose of this event is to familiarize you with the Kaggle website. So we'll be showing you all the features of the website and how you can use it, basically. As well as, we also have like pro tips from a very seasoned Kaggler who is here with us, Mr. Naman. So this hopefully will give you a head start when you start using it. Yeah, but before we go to that, I want to talk about our next event. So we have like an NumPy and Pandas workshop coming up soon. So if you're new to machine learning but you would like to learn more, this is a very great opportunity to do it. We also have a scikit-learn workshop, which would also again be very useful for any data scientist or machine learning expert. If you're familiar with those or after you've attended them, you can join our Titanic Dataset hands-on workshop. So in that event, we will actually go through a competition on Kaggle, and therefore you will be familiar with like how to do the competitions, and you will be confident doing bigger projects later on using like the machine learning and what you've learned. After that, we will actually have our Kaggle Teams plan started. So what we plan to do is, split people into teams, people who are interested in doing machine learning, and then basically, yeah, just split them into teams of 5 and have them go at Kaggle competitions together. We'll also have like discussion forums so people can share like notebooks and tips about what they did and to help each other out. Yeah, moreover, we also have like events coming up with the Future Conference, which is a multidisciplinary conference taking place at the University of Edinburgh. It's all online, of course. We will be participating with 2 events, the first of which is a coding competition. So if you actually want software engineering jobs, then, I would highly recommend this because, the questions there are what are asked in interviews usually. And there are prizes available for like if you perform well. So, make sure to attend that. Moreover, we also have like a talk with Dr. Chatinkaya Randall, who is an expert in the field of AI and data science. And we are honored to have her talking about growing your inner data scientist with us. So make sure to check that. We also have a position open for the social media officer. So anyone is welcome. You have to be a University of Edinburgh student, but other than that, then even if you're like first year, second year, different field, doesn't matter. Everyone's welcome. I believe it will be good experience for you if you want to do other jobs later on. The skills you learn in that role are very transferable. Also, it'll be a great opportunity to get more involved with the society and what we do. So hopefully, if you like what we do here and want to get more involved, then please consider that. We'll open up the basically applications later on. So yeah, just follow us on social media to find out more about that. And please do buy our membership. And so we have here the social media links. They will also be on the YouTube chat and in the YouTube description. And please also, yeah, as I said, buy our membership because that is our main source of income. And it's like £1 for University of Edinburgh students, £2 for non-students. So if you like our events, then please do buy it. The purpose of like the membership is to get priority on our events. So we will not have unlimited availability, unfortunately, for all our events. So members get priority. So if you like what we do and want to get involved, beat the queues, pay the extra £1 or £2, and yeah, you won't regret it, hopefully. Cool. So that's it from me. I hope that you enjoy the workshop, and I'll be transferring to Naman now. Yeah.
Hello, everyone. This will be the introduction to Kaggle talk presented to you by Ed Intelligence. My name is Naman Makkar. I'm the competitions leader of Ed Intelligence, and I will be introducing you to Kaggle. So, as some of you might know, Kaggle is an online community that consists of data scientists and machine learning practitioners. It's a place where we can publish and use various datasets. It allows us to use web-based Jupyter notebooks with free access to accelerators such as GPUs and TPUs to build and train our machine learning models. It's also a useful place where we can both compete and organize online competitions that seek to solve a machine learning problem, be it analyzing pulmonary chest X-rays for lesions, or be it motion detection in autonomous vehicles. So let's get started with Kaggle. So first of all, we just go to the homepage. As you can see, this is the Kaggle homepage. If you already have an account, you just need to sign in right here. If you do not have an account, just click on register. You can register either with your Google account or with your email account. You can sign in with either a Google account, your email account, or even your Facebook or Yahoo account. But generally speaking, it's recommended to create an account with either Google or another email ID, because it just makes it easier for you to use the API and the command line interface. With Facebook and Yahoo, you cannot do that. So once you've made the account, your Kaggle homepage will look something like this. This is my Kaggle homepage. And now we can move on to Kaggle datasets. So in order to move on to Kaggle datasets, just go to the tab on the left-hand side and click on data. This is where you can see all the public datasets which are being shared by Kaggle users. You can even see your own datasets right here. Well, one of the reasons for making private datasets of your own is that you can save your own model weights or model architecture that you want to use later on. Trained models that you've trained yourself, you can easily use them later on. So for example, this is a submission ensemble that I've created for some competition of mine. As you can see, these are the files that I've created over here. You can download datasets from here. You can go to settings. If you click on sharing, you can decide whether it's private or public. You can click on make public if you want to make it public. Or if you want to share it with a bunch of selected users, you can just search for the users right here. Going back, you can create a new dataset by clicking on new dataset right here. This allows you to drag files and folders from your own machine to this place to upload them into your dataset. You can even use a bunch of remote URLs to make a dataset. You can even use your GitHub repositories to make a dataset. For example, you have a pre-trained model that you coded on and you posted the code in a GitHub repository. You can just use the GitHub repository instead of coding it from scratch in a Kaggle notebook. So this is very useful for that purpose. You can also make datasets out of the outputs of other people's notebooks. So let's say you want to use someone else's data or you want to use someone else's models. It's very simple to just make a dataset out of their notebooks. You can decide whether to make it private or public by clicking this toggle. Private datasets, as it's pretty obvious, are available only to you, whereas public is visible to everybody. You can click create to create a dataset. That's all about datasets. Now, let's move on to Kaggle notebooks. So in order to access Kaggle notebooks, what you have to do is click on the tab on the left. As you can see, all of these notebooks are the most trending public notebooks from various competitions organized on Kaggle. You can click on these notebooks and view other people's codes. To draw inspiration, from them. As you can see, there's someone else's code. You can even comment on other people's notebooks about what you think of their code. You can even ask them questions about their code. You can even see your own notebooks right here, your own private or public notebooks that you've made. You can also see your GPU quota and your TPU quota. This gets updated every week. So for example, every week you have around 37 hours of GPU access and 30 hours of TPU access. All this gets updated every single Saturday on Kaggle. You can click on a new notebook. You can create a new notebook by clicking on a new notebook right here. And this allows you to choose from a bunch of settings. Here you can select your language, whether it's Python or R. You can select the type of your notebook. You can either select a notebook, which is just a regular Jupyter notebook, or you can select from a script. The difference between them is that a notebook is one which has multiple coding cells. So it allows you to distribute your work into data analysis, data visualization, model training, and model testing. Whereas the script is basically just similar to a regular text editor, which doesn't let you divide your project. So these are ideal for model testing and model training only. Whereas notebooks are ideal for data science projects, data analysis, and data visualization. You can even choose from advanced settings. For example, you can choose your accelerator if you want a GPU or a TPU. Generally speaking, if you're doing a deep learning project, it's a much better idea to use the TPU over a GPU because they're specifically built to accelerate matrix multiplication, which is very useful in neural networks. You can even link your Google Cloud account by clicking on right here. This allows you to use a bunch of services offered on Google Cloud, like BigQuery, Cloud Storage, and AutoML. AutoML is a new technology that allows you to basically build a model by writing almost no code whatsoever. They just build a model and you can test it. You can link your Google Cloud platform account by clicking on link account right here. You create a notebook by clicking on create right here. As you can see, this is the new notebook. And this is the first coding cell that's present by default in all Kaggle notebooks. As you can see, they import the linear algebra library called NumPy, as well as the data processing library called Pandas. They also import the OS library, which is helpful for viewing our files. We can add data sets to our notebooks to work with data by clicking on add data right here. This allows us to choose from all the public data sets on Kaggle, the ones we just saw. As you can see right here, AV Healthcare Analytics, archive dataset, just like we saw on the dataset page. We can even choose from competition datasets. For example, the OSIC pulmonary fibrosis progression. This is a competition. As you can see, this is the prize money of the competition, $55,000, which is available to the prize winners, with 1,915 teams competing. You can click on add to add the dataset. As you can see all of the files in your data in the input section right here. You can run a coding cell by clicking on Shift plus Enter on your keyboard. And this allows us to see all of the files present in this dataset. You can create a new coding cell by clicking on plus code, or if you want to create a new markdown cell to write a bunch of text to explain your code or write down your ideas, you click on plus markdown, for example. It's very simple. You can choose your accelerator right here. Once again, between GPUs and TPUs, you can even change your language from Python to R or R to Python. You can toggle your internet on or off, depending on whether you want to pip install a bunch of packages, a bunch of libraries. For example, let's say you have a model that you do not want to code from scratch. You can toggle the internet on or off. to install that model on your notebook. You can save your code by clicking on Save Version. This allows you to save your code in two different ways. You can either do Quick Save, which just saves your code, does not save the output of your code, or you can do Save and Run, which saves both your code and the output of your code. This for obvious reasons takes longer since it runs all of your coding cells. This would the duration for which this will go on will depend on how long you're training your models on Kaggle. You can share on Notebook by clicking on Share right here. By default, your notebook will be public. If you want to make it private, just click on Private right here. If your notebook is private, you can search for users, for example, people in your team or your friends that you want to share your notebook with. You can add tags, for example, deep learning, so that people find it easier if your notebook is public to view your notebook. If you do not want people to comment on your notebook, you can click on Turn Off Comments and you can save these settings. Here, you can see your session metrics. This tells you how much memory you're using in each session. So for example, let's say you're using a GPU or a TPU. You want to make sure that you're not exceeding the available memory limit, because if you do so, your session will restart and all the progress you've made will be gone. This has happened to me on countless occasions when I was selecting a huge batch size and I repeatedly exceeded the memory limit, which resulted in the session restarting and me losing all the progress. You can click on Stop Session right here to stop the session. You can click on Restart Session to restart the session. You can view session metrics from here as well. The same thing. There's an added feature to Kaggle, is that you can upgrade to Google Cloud AI notebooks. Now, this allows you to link your notebook to your Google Cloud account to get more compute power. So for example, you have 37 hours of weekly GPU access on Kaggle notebooks and 30 hours of weekly access to TPUs on Kaggle notebooks. If you want to increase your compute power, let's say you want 50 hours, you can link it to your Google Cloud account. We will be giving you a bunch of links, useful links that will help you to do so. They will basically guide you through the process of doing so. You can change your title right here, for example, new sample notebook, and automatically saves your draft. You can run all the cells at once by clicking on Run All. You can even click the cell you're currently in by clicking on this button. You can even cancel run by clicking on this button. And yeah, that's all about notebooks. Are there any questions? Okay then.
Hey Naman, there are two questions. I'm gonna read them out from the doc. So the first question is from Varun. He asks, what is the difference between GPU and TPU?
Okay, so the difference between GPU and TPU is that TPU has a domain-specific architecture for deep learning, whereas GPU is just a graphic processing card, which is useful for playing games and all sorts of stuff. TPUs are specifically built for enhancing matrix multiplication. So for example, they have low precision, they have matrix processors and things like that, which basically accelerate the matrix multiplication process, which is what we basically do in neural networks. For that reason, TPUs are simply better than GPUs when it comes to deep learning. Are there any other questions?
Yes, there is one question from Valley. He asks about the save and run code option. The question is, if you already ran all the code cells and made no modifications, is it going to rerun everything again?
Yeah, so if you just run, let's say you run all the cells right now, it won't save the output. You're just running it for yourself to check what is on the code cells. If you want to save your code, if you want to save the output of your code, you have to click on Save and Run here. So it basically runs everything again and runs it so that you don't have to supervise it, runs it on its own and stops when it's done. Are there any other questions?
There are no more questions, so hopefully all the questions were answered, and if not, then please keep posting them in the chat. Thank you.
Okay, now moving on. Now we move on to Kaggle competitions. So this is the competitions page of Kaggle. You can just click on compete on the left-hand side. These are your competitions, the competitions that you're already competing in. And these are all the competitions on Kaggle. On Kaggle, there are two types of competitions. First, there are paid competitions that are organized by various companies. And then there are knowledge-based competitions which are organized by Kaggle. For example, the Titanic Machine Learning from Disaster competition, which we'll be making a workshop on, is a knowledge-based competition just to enhance your machine learning skills. You click on a competition page to access the competition. So for example, this competition. Here you can find the rules of the competition. If you want to compete in a particular competition, you have to accept these rules. So if you just click on join competition right here and click on I understand and accept. So coming to the overview of the competition. Here, this basically contains a description of the competition, which is given by the competition organizers. You can see prizes, timeline, evaluation, description. You can read it if you want to. Coming to the data part of the competition. This describes all the data in the competition files. This describes the data set of the competition. As you can see, we are provided with 3 .csv files, which are comma separated value files. These contain the data that you're supposed to work on. It's a data science competition. You can download this data set by clicking on download right here on your machine, or you can even use your command line interface to download this. We will be releasing a bunch of useful links on how to use the command line interface to download certain data sets on Kaggle. We'll be making it public in one of our slides. Moving on to competition notebooks. Now, these are different from the notebooks that we saw before. These notebooks are just specific to this particular competition, and they're not from any other competition. You can click on any one of these notebooks once again to access them. You can copy or clone their notebooks if you want to by clicking on copy and edit. This is generally speaking a very good idea for beginners who are just getting started with coding on Kaggle, so that they can take inspiration from other people's codes and even improve on their code. As you can see right here, their code has been cloned, and I can edit it on my own notebook now. Going back, you can once again comment on people's notebooks to ask them about their code. You can even check their output or their input to check what all data sets they have used and what all are they generating in this particular notebook. As you can see, he's generated a submission file .csv, which he will submit to the competition. So in a Kaggle competition, you're basically given a data set, which is divided into test set and train set. You're supposed to train your model on the training data set, and you're supposed to run it on your test set, and you're supposed to submit the predictions of the test set in a form of a .csv file. That is the file you submit, and that is the file on which they calculate the score. Every competition has a competition metric, which depends on the problem that is given in the competition. For example, if it's a linear regression competition, the competition metric would most likely be a mean absolute error, or it could be anything else. For example, if it's a classification problem, it could be an F1 score. That depends on the specific competition that you're competing in. Once you submit your files, submit your predictions in a .csv file, your file is scored on the basis of the competition metric. There are two types of leaderboards. One is the public leaderboard, the other is the private leaderboard. The public leaderboard is usually evaluated on minority of the test data, either 50% or less than 50%. In this case, you'll see it's 50%, but there are competitions that I can show you it's even 8%, as low as 8%. Private leaderboard is calculated on majority of the test data. This is the leaderboard that you can only see once the competition has ended. Whereas the public leaderboard is the leaderboard that you always see, even when the competition starts. So generally speaking, it's a very good idea to avoid overfitting on the public leaderboard. Overfitting is when you overgeneralize your model to understand the features of only the dataset of the public leaderboard. So you're basically performing well on minority of the test data and performing poorly on the majority of test data, which is on the private leaderboard. There have often been cases when my model performed very well on the public leaderboard and performed horribly on the private leaderboard, caused me to lose a few hundred places simply because of the fact that I was overfitting on the public leaderboard. So during a competition, when you keep improving your rank, you are doing so on the public leaderboard, not the private leaderboard. If you want to submit your predictions, you have to click on Submit Predictions, and you have to create a new notebook here. Going back to notebooks, there's another way of adding data sets. To your notebook. For example, as you can see in the input file, the dataset is already here. This is basically similar to the way we did it before. Instead, here we do not have to click on Add Data to add a dataset. It is there by default, since we clicked on New Notebook in this particular competition. That is the only difference from before. Moving on to the discussions forum. This is a very good place to look for different teammates that will compete with you and basically help you out with your submissions. This is also a very good place to ask for help if you're stuck, ask for suggestions to try new strategies to approach the competition. Generally, a very good place to ask questions and interact with people. This will increase your knowledge, and this is recommended for beginners. Moving on to the Teams tab of the competition. This is where you can create your team. You can change your team name right here. And you can merge with other teams or invite other users to your team by using their team name. You have a limit of 5 members per team. This can sometimes be a problem since you are limited to a limited number of submissions every single day. So let's say if you're competing individually, you're limited to 5 submissions a day. And if you're competing with 5 people in your team, you're still limited to 5 submissions a day. That can be frustrating since, let's assume, you're capable of generating around 10 to 20 submissions a day. You're only getting to do 5 submissions a day. And your team is capable of generating around 50 submissions a day. They still get to submit 5 submissions a day. So that is the cost of having a team on Kaggle, unfortunately. This is your submissions tab. This is where you can check your team submissions. This is the status of a submission, tells you if it's complete or not. This gives you the score of the submission on the public leaderboard. This is the score of the submission on the private leaderboard. And that's about it. Are there any questions?
Yes, there are some questions. The first question is from Sadiq. He asks, how can we rank our data set?
Rank your data set. I don't think the question is very clear. I don't exactly understand how you rank your data set.
Okay, maybe Sadiq, could you be more specific about your question? And in the meantime, there is another question from Guaraf. I hope I pronounced the name correctly, and if not, I'm really sorry. What do you mean by session here? And losing data after exceeding memory?
Okay, so if you go back to a notebook, a session is basically something that allows you to run your code. So if your session is not active, so for example, if you do not see the green light here, you simply cannot run your code. Draft session has a certain RAM memory, random access memory. If you let's say you're using your GPU and you exceed this memory limit of 16 GB, your session will automatically have to restart because it won't have any memory left on it. And since it restarts, all of your progress will basically be lost, since you won't be able to run your code anymore because your session is already restarted and it's not working. You need the session to work for running your code. So that's something that you have to keep in mind. Any more questions?
Sadiq is back. He meant, how can we rank our notebook?
Oh, rank your notebook. What do you mean? Do you mean, does he mean that you can commit your notebook and make it public? I don't know what do you mean by rank your notebook. It's not very clear to me. I've never heard of that, ranking your notebook.
Okay, so if the question is clarified, we can ask it again. But if not, then we can just move on because there are no more questions. Other questions were answered in the chat.
Okay, so we can move on. So now we move on to the discussions forum on Kaggle. So if you want to access the Kaggle discussions forum, you can click on discuss on the left-hand side right here. As you can see, discuss. Now this is different from the competition discussion forum. This is just a general purpose discussion forum where you can post on any topic related to machine learning. As you can see, you can even post your own data set if you have it and you want to, let's say, advertise it. Let's say you have a public data set that you just published and you want to advertise it to a bunch of people. You can even publish it right here so that other people can look at it. Same for notebooks. If you have a public notebook that you want to advertise so that other people watch it and upvote it, perhaps that's what Sadiq meant by ranking a notebook. Maybe you can do it right here. You can also ask questions related to machine learning, which is a very good recommendation for beginners who are just getting started with Kaggle, or just data scientists who are just getting started with their careers. You can just ask questions right here by creating a new topic. For example, click on question answers and create a new topic. You can write a title and ask your query right here. You can even look at other people's queries and learn from them. There will always be a bunch of people who are willing to help you and willing to interact with you on Kaggle in discussion forums. This is a very good place to gain knowledge in general. That's all about the Kaggle discussion forum. Now we move on to Kaggle courses. Are there any questions?
There is actually one really good question from Michael. And the question is, what would be good, or like the question is in a sense, what would be good as a first step to start as a beginner? Like, should we join easy competitions, or how should we start? And I think you're going to elaborate on it by talking about the courses, but you can take the question now if you want to.
Yeah. So one of the ways to get started on Kaggle is to follow these courses. Kaggle offers some great courses on Python, intro to machine learning, feature engineering, pandas, data visualization, deep learning, natural language processing, as you can see. These are all free courses and they're really, really good that you can do these courses and get started with knowledge-based competitions like the Titanic dataset or the MNIST recognition competition. It's usually a good idea to get started with the knowledge-based competitions to build your machine learning skills before you get started with the prize competition because they're much, much harder. So if you're a beginner getting started on Kaggle, I would recommend that you first just do the Kaggle courses. After you've done the Kaggle courses, if you have a bunch of doubts, you can once again go to the discussion forum and clear your doubts by asking questions. And then once you think you have gained a bunch of skills, machine learning skills or data science skills, you can then start with the playground competitions. For example, the Titanic machine learning from disaster or the digit recognizer, which is the computer vision competition for MNIST recognition, or the real or not NLP with disaster tweets. These are fairly simple competitions aimed at beginners who are just getting started with machine learning. And you can basically do these. So first of all, you're supposed to do the courses on Kaggle, then maybe ask doubts in this discussion forum. Then you get started with the knowledge-based competitions on Kaggle. So that's it. Any other questions?
There is actually another interesting question from Tanya, and the question is, what is a good data set available for beginners to start with a univariate or multivariate regression machine learning model?
Well, I mean, I don't exactly remember what data sets are available, but you can basically search for data sets right here. I don't remember it at the top of my head, a good data set for beginners, but you can search for data sets right here if you want to. We will, perhaps I will look it up and let you know, and we will make it public. Maybe on Facebook or on YouTube, we'll let you know which data sets you should do for beginners, but I don't remember it off the top of my head. So, any more questions?
That is everything for now. Thank you.
Okay. So, that's all about Kaggle courses. We move on to jobs offered by Kaggle. If you're some data scientist who's seeking for a job, you can click on subscribe by email, where Kaggle basically lets you know about certain job offers, and maybe they basically send you an email notifying you. You can even look for jobs right here. As you can see, PhD or postdoc in machine learning. If you want to apply for the job, just click on apply now. It's as simple as that. If you're a startup who's looking to hire data scientists, you can even create a job listing right here. So just scroll through if you want to. If you're someone looking for a job, you can just scroll through this list. And if you're a startup, you can just create a job listing. That's all about Kaggle jobs. We also have a bunch of slides on the summary and the pro tips for competing on Kaggle. We also have a slide on a bunch of useful links that we will be making public to everyone. First is the using Kaggle API for downloading datasets using the command line interface. You'll also be giving out a link on how to use your Google platform account to increase your compute power with GPUs and TPUs. I think that's all. Are there any more questions? Please feel free to ask questions.
Okay, so there's one new question from Nikhail. I'm really sorry with the name. I cannot pronounce it. Please, could you tell a general approach to start with machine learning? when we have prior experience of coding in C++, I'm not able to find a way to start with machine learning.
So once again, a good way to start will be, I think, if you just look at these courses like Intro to Machine Learning, Pandas, Feature Engineering. If you're starting with C++ and you do not know Python, first it would be a really good idea if you learned Python or R or in any data science language. Usually speaking, since it's not very easy to do data science in C++, it's generally speaking a very good idea to do Python first. So just look at these Kaggle courses first. First do the Python course, then the Introduction to Machine Learning, and in this order, you can learn a lot. It's also a good idea if you want to check out a bunch of Coursera courses. For example, the machine learning course by Andrew Ng. It's one of the most famous courses on Coursera. You can check that out. It's for free, I think. So yeah, that's basically how you get started with machine learning. As I said, please look at these courses. If you're someone who's getting started, these are very useful. Really help you in your data science career. Any other questions?
There's a question from Sadiq, and the question is, is EDA modeling, in EDA modeling is necessary?
What exactly do you mean by EBA? I don't think that's I don't think that's a specific question to Kaggle, but I don't think it would be necessary. I mean, I don't exactly understand what they mean by EBA modeling.
I think it means exploratory data analysis.
Oh, EDA.
Which is a term
okay,
yeah.
EDA.
Yeah.
No, it's not necessary. You can do it if you want to, but not necessary. That's something that you have to suit your taste. Sometimes you do not do exploratory data analysis. Sometimes you don't need it, but sometimes you have to. So that would depend on the problem you're solving, the data set you're running, data set you're doing it on, or the competition that you're doing. So that's specific to a particular data set or competition. You don't have to do it every time. So, any other questions?
There's another question from Sadiq, which is, which should we start first, machine learning or deep learning?
You must start with machine learning. First of all, you have to start with Python, NumPy, Pandas. Then you get started with machine learning and data science. Then once you've mastered those, then you go on to machine learning. Then you go on to deep learning. That's how you do things.
There's another question from Tanya, which is, do these machine learning models require knowledge of big data and technologies such as Spark or Hive?
No, they don't. They really don't. All you have to know is Python and machine learning, big data, and using Spark. Those are subsets of machine learning, but you really don't need those when you're coding on Kaggle. It's usually not required. It's a good skill to have for looking for jobs, but generally speaking, you don't need that on Kaggle. Any other questions?
Kyle is asking if there is a need to study mathematics before studying these machine learning courses. Like if there is some course, for example, on Coursera that is focusing on mathematics that you would maybe recommend.
Yes. So before studying machine learning, you should definitely do a bunch of mathematics courses. So for example, you should be really good at linear algebra and calculus. Those are necessary for an understanding machine learning. So if you go on Coursera, there should be a bunch of courses on mathematics for machine learning. You can search for courses on mathematics for machine learning and study from there, linear algebra and calculus mainly. Those are important. Any other questions?
Great. Then Varun asks if there are any prerequisites needed before starting working on Kaggle.
Prerequisites. I mean, once again, you can, for example, if you haven't studied these math courses, for example, you don't know linear algebra or calculus, you'll have to study those first. And If you don't know how to code in Python, you can even learn that on Kaggle, or like most people, you should maybe perhaps learn Python first and then get started with machine learning on Kaggle, Python, or even R. Either of those two languages, you should ideally know them before you get started with Kaggle. So that is what I would recommend.
Great. And then there was a question from XJJ, which is what kind of knowledge should we take if we want to join Kaggle? But I believe you have just answered it.
Yeah, you basically should have knowledge of linear algebra, calculus, and machine learning, and you should also know how to code in Python or R.
Then Sadiq is asking how much accuracy is best for a model, which I don't think you can answer, but
yeah, that's actually a very specific question. It depends on the specific data set and the specific competition. For example, let's say you run a model, it might have a very good score on the public leaderboard and a horrible score on the private leaderboard, but that's because you were overfitting on the public leaderboard. There isn't really any best score, generally speaking. I mean, you all you can do is like improve your accuracy, but I don't think there's a best score. This is just very subjective, accuracy on models. Any other questions?
Adi Mulem is asking if data structures and algorithms are they important in machine learning?
They're important if you, let's say, you use Python, right? Data structures might be important, but algorithms not necessarily. There are some competitions where you use a genetic algorithm and use it in machine learning, but for the most part, not necessarily. They're not really that important. I think data structures you should already know to become a good Python coder or good R coder. So I think data structure you should already know, but I'm not it's not that algorithms are not really that required. They're not that necessary on machine learning.
There's another good question or good point from Branyo. And the question is, do you know why we should study the basic machine learning and data science before doing deep learning? I know it is always thought like that, but I don't quite see why one couldn't just start with deep learning and skip the old-fashioned methods.
I mean, the problem is like the deep learning is based on machine learning. Deep learning is a subset of machine learning. So, and machine learning is a subset of data science. So there's no way you can completely understand deep learning if you do not study machine learning properly, because it's a subset of machine learning itself. So it's ideal to study data science and machine learning before you move on to deep learning.
There are two more questions. So It's Secret is asking if this was just like a single session or if we are planning on to take series of sessions teaching machine learning. So I guess this is a great opportunity for you, Namat, to introduce them.
So we will be having multiple workshops. The first workshop we'll have is on NumPy and Pandas. Then we'll also have a workshop teaching scikit-learn and machine learning to beginners. Then we will do a workshop where we will compete in the Titanic competition and show people how to do machine learning with NumPy, Pandas, and scikit-learn on that competition. So we will be holding multiple workshops for machine learning and deep learning. It will be coming up in the near future, definitely. Any other questions?
Are there any maths books recommended by you that you would definitely recommend for machine learning or ways to study?
There's a book called Elements of Statistical Learning. It's generally a very good book, but I think first of all you should, before studying machine learning, you should make sure that you know linear algebra and calculus, and there aren't really many books that I could recommend. I mean, You can even do online courses or just look for any books that are available for free online. Not any specific book for linear algebra or calculus. They're really not that complex topics, but for machine learning, if you want to get started with it, the first book I would recommend is The Elements of Statistical Learning. Any other questions?
There is a question that is quite interesting, and it's from Michael. He is asking whether employers generally look for experience in Kaggle or if they consider it.
Who looks for experience?
Employers.
Employers. Yeah, they do look for experience in Kaggle. So, for example, if you're applying for a job and you have a bunch of Kaggle experience, let's say you're ranked in the top 10% of a competition or top, let's say 5% of a competition, I think employers will be really impressed with that, and they'll be interested in knowing. As you saw in the job section, there are a bunch of people from different startups and corporations that are looking for a job on Kaggle. For example, Optiver, it's looking for a data engineer. So yeah, employers are usually very interested in Kaggle, in Kagglers, generally speaking. So it's good for improving your data science career. Any more questions?
Yes, there is a question from Harsh, and the question is, should we go for Python or R as a beginner? Does any of them give some extra advantages?
Well, most machine learning practitioners tend to prefer Python over R, but there aren't many advantages if you're choosing R over Python, but certain people tend to prefer R. But majority of the community does Python because it's simply much easier to do deep learning using Python rather than R. So I think it's a question of taste. You'll find a lot of data scientists who prefer R as well, but I think Python is simply the best.
Okay, there's kind of last question that was not answered yet, and the question is machine learning a subset of AI?
Yes, absolutely. Machine learning is a subset of AI. There are also other subsets inside AI. Machine learning is just one of them. So yeah, that is correct.
And then Tanya also asked, what book would you recommend to learn about the fundamentals of machine learning for beginners, if there is a specific book?
Wait a second. So there was a book called Deep Learning. I can actually show it to you. Okay, this book called Deep Learning, this is written by Ian Goodfellow, who's a deep learning researcher at Google, along with Yoshia Benjuyo and Aaron Cole Curville. This is a really good book if you want to get started with deep learning. But in general, before getting started with deep learning, I would recommend that you increase your knowledge in machine learning and master machine learning, and then you move on to deep learning. This is a very good book for an introduction to deep learning, and it's highly recommended that people look into this once they've done machine learning.